go, is record. And so I would like to do that. Hopefully I can get everything recorded. I'll get you guys. But there we go. So chapter 34. We're going to start there pretty much with this class. We're advanced solid state, right? So now we're going to start looking at pretty much the first half of the class. We'll be looking at amplifiers, different types. In the beginning, it'll be transistor style amplifiers, which aren't as commonly used today, basically just because everything's in a chip. So a lot of what they'll be doing is for like higher end amplifiers and stuff they use operational amplifiers. They're much more robust and whatnot. But in the beginning, that's what they did. They had transistor style amplifiers, and there still are some out there as far as like low ones. But yeah, we'll be looking, if you look here, the topics covered, right? Types of amplifiers, our frequency response. And of course, just like anything else, is like an RC circuit, RLC circuits, we do have a certain amount of bandwidth that's allowed. Oh, Jesus. But anyway, and another thing that they look at is the decibel gain, decibel voltage, decibel power. We'll also be looking at something called impedance matching, which is somewhat related to something I talked about a little bit before. I never gone totally in depth in it on superposition theorem. And the reason you want to try to match impedance up is overall you want to avoid as much feedback or reflections in your circuit as possible. So by matching impedances from like the source up to the output, what you'll do is you'll set it up so more of the power is absorbed where it should be, and you get less reflections back on your line. Because what'll happen is if you get a lot of reflection, something that they call attenuation happens. And you want to try to avoid that, because attenuation, well, it's like a feedback, and what it'll do is it'll literally distort your output signal to the point where it's not usable. And then we'll look at something I know everyone's going to enjoy is Bode plots. I'm not going to go really in depth with these. One, it's going to be impossible because we need a special kind of graph paper for it and everything. But the book does go through it, and that way at least you'll be able to look at it and be able to recognize them. And what it is, it's more of like a frequency response of a particular amplifier. So if you had one set up and it had a specific output set to it, the Bode plot would record it through, and you could see what the responses would be. And it's kind of how they pick, like if an engineer is going to go out there and he's going to pick like a type of amplifier he wants to use, he would look at the Bode plot and compare it, and it'd be like, see if that's the type of thing he wants. And we'll look at bandwidth. We will be studying bandwidth. So of course, everything we're going to be looking at is going to involve AC. Excuse me here. So the way they do it, it's and essentially it's two basics, right? You're either you're going to amplify the amplitude of the signal, or B, you're going to amplify the frequency of the signal, right? And the funny thing is, and if everybody's used to radio, these are two types of things they have, right? AM is amplitude modulation, and FM is frequency modulation. So that's basically like the two major ones that we use out there, and that's how you tie that in, just something you recognize. So, but yeah, from radio, that's what they do. It's amplitude modulation or frequency modulation, and that's the kind of thing we're going to be getting. I mean, not real in depth, right? We're not trying to be engineers here, but if we look, all right, so with the amplifiers, of course, your signal levels, you either have small or large signals. And like it says here, small signals are generally less than 1 or 2 volts. And I will say this, for amplifiers, you do want to go through more with small signals, because if you go with a large signal on an amplifier, and you try to amplify that, you're actually looking to cause more distortion, which is something we try to avoid. For typical amplifiers, there are some out there, of course, that they do, large signal amplification for, and that's more for like power type things. If you're, I don't know, if a musician, right, you're using like your amplifier for your guitar or something like that, you will have more of a large signal type amplification going on with that. But I don't think we're going to be doing a whole lot of that. Most of our stuff will be, you know, low level, small signal voltage amplification. And then he lists off the types of amplifiers out there, right? Commonly DC. DC is nice. It's easy, simple. We don't have a whole lot of fluctuation going on like with an AC signal. So of course we don't have the noise to worry about and things like that. So DC is easy to do. And audio and video, and we use that a lot out there these days, right? With all the media, radio, television, cable, all that. And RF amplifiers, well, that's radio frequencies, and what that'll be, it'll be like broadcasting type thing. So if you had like the AM with the amplitude modulation, or FM, right, FM modulation, you'd be looking at our RF amplifiers. And then more and more lately, like especially with the high speed transmission, I don't know if you've ever seen like on the highway with those really large towers with the great big white dishes on those. Well, those are microwave transmitters, and of course, then we're looking at microwave amplification. And the reason being, it's all about bandwidth. So if you go, at the beginning, the AM, it was low bandwidth. FM was a higher bandwidth, and as you move up the spectrum here, we go like VHF and UHF, which was the early television signals, right? What they had, and then because the UHF is ultra high frequencies, that kind of thing. Excuse me. But we're gonna go look at this. I'm excited. I know everybody else is probably gonna be like, oh my god, but no, this'll be good stuff. We're gonna go slowly. And like I say, we'll go through chapter 34 and pretty much in sequence here, 34, 35, 36. So if anybody wants to look ahead, like what we're gonna do and things like that. And yeah, we are gonna be using the Frenzo book, but I just like last time, I will try to incorporate some of the Malvino stuff for just like an easier explanation, if you will. But this beginning chapter, I was looking through in Frenzo, and he does actually a pretty decent job on this part, just so we can recognize everything. But and then start off with the DC amplifiers. We got audio amplifiers, video amplifiers, and we'll be taking a look at some of that. In the beginning here, like I say, we're gonna primarily stick to the transistor styles, and then in chapter 35, that's when he goes into op amps. So I want everybody to get kind of used to the concepts of amplifiers and how we're going to be looking at things. And so the big thing, a big thing we'll be looking at, here we go. So frequency response, right? So a lot of times you'll be looking, let's say at a circuit or something like that, and you'll see a graph of the voltage gain versus the input frequency. And basically that's kind of like a measure of how well the circuit's going to perform. And so then we know what our limitations are. I know, okay, but with like an AC amplifier, you have a lower and upper cutoff. So it's only going to allow, just like in an RC circuit or an LC circuit, RLC, you depending on the values, you are limited to how much what your bandwidth is going to be, or what your response is going to be of that circuit.
Hey, Tom.
And you'll see here he specifies that a DC amp only has upper cutoff frequency, so it will allow low frequencies to pass through or be utilized, if you will.
Hey, Tom.
And of course, just like and that's why we learned, RC circuits and things like that, because that's what they use. So we're going to use coupling and bypass caps to do cutoffs. So, and it'll allow us to pass through the bandwidth we look for. And with like an AC response or frequency response, you will have like a lower limit cutoff, and you'll have, oh, yes, sir.
Hey, Tom, you're up.
Oh, hold on here, Ben. I don't know why this is,
Spamming the raise hand button.
my speaker volume is not coming through really well, and I don't know why. Yeah, I know, this is horrible, right? Hold on here. Pause this. I don't know. And I don't know if it's the interaction with this program.
Yeah, because all we've
Or
been
I'm
seeing
just a
is the first slide of
fool.
what you're hearing. I don't think the slides haven't changed for us.
Let me try that. Try talking again, Ben.
Hello? You hear me?
Oh,
Are you
there
there,
we go.
Tom?
My God, I totally apologize. For some reason, I had my digital output configured for my speaker output. Yeah, you can tell I'm right in there with the whole PC thing, right? No. But yeah, what was the question?
I don't
So
think
you're
we can see what you're seeing on your computer, because right now it's just stuck on the first slide.
The PowerPoint slide is?
Yeah,
Yes.
unless you haven't changed
Is it really?
Yeah.
You know, see, now I don't know if that's, let me see here. Really, it's stuck on the first frame.
Mm-hmm.
Yes.
Awesome. All right, hold on here. Let's see. Yeah, because see, for me, I have the sharing going on. I don't have it paused. And I'm running. Hold on. Let's try. Let me try How's that?
Better.
There we are.
Oh, is it
There we go,
scrolling?
yep.
Oh my God. Well, like I said, this would be a. Oh, all right, hold on here. I gotta go back. Well, awesome. And then the best part too is I'm starting to run out of time. Okay. Well, all right. Well, here's what I was kind of talking about, right? There's your overall frequency response, or the frequency response of an amplifier. Now you'll see it's a weird looking little camel hump there, right? And really the way to look at that is what's allowable. So like F1 there would be like our beginning, because that's basically where we're allowed to pass through. And so any frequency that's below that would be rejected by this, whatever circuit this is, right? And then if you look at F2 here, that's our like maximum upper allowable. And then they refer to something we call AV. Now this is a term, or this is something I want us to get used to seeing. And what that is it's actually the Greek letter alpha, and with the V designation or subnote, right? We say AV, which would be specifying the overall voltage gain of this particular circuit. And generally the way they do that is they'll have AV, it would be equal to, and then what you would see spelled out would be the output voltage divided by the input voltage. And then generally after that, you'll see it equal to some type of equation for that particular circuit, right? Excuse me. And that's how they look at it, and that's a very typical graph that we would see for a bandwidth allowing. So, and you can see how the graph spells out the mid band, or so for your particular circuit, that would be your allowable frequencies. Oh God, there we go. And of course, this one would be like I was saying earlier with the DC amps. The DC amps allow all the lower frequencies to come through, right? And then it just cuts off at the higher frequencies. So you don't see that camel hump in this particular case, as it is allowing everything up to a certain point to go through. And I haven't assigned, oh God, let me see. Oh, awesome. I have 6.5 minutes left of this wonderful meeting. And hopefully yeah, this whole coronavirus thing's been crazy. Anyway, but no, as we look through it and then we get used to our hearing bandwidth, it's like bandwidth, what does that mean? And that is exactly it. So your bandwidth is the lower to the upper allowable frequencies of that particular circuit, or that's what you're allowed. And even when you look further, when you start getting out there, right, you'll start seeing even tables listed out, like with the AM allowable. And AM has a specific frequency range. FM has a frequency range. VHF, UHF, and these actually go up higher and higher in frequencies, and there's a range to it, and that would be drawn out with that same type of graph where these are the allowable frequencies in here, and then rejecting anything up over that, and rejecting anything lower. But they have it listed all the way through microwaves and everything else. So as you go through the book, that's really what he's talking about, your upper and lower cutoffs. And here we go. Now this is this should be a new concept for pretty much everybody, and you will see this on amplifiers. They will say what the decibel power gain is. And in one way, I mean, I don't know if everybody thinks of like decibels, we think of sound, and in a way that's correct, but not quite. Because the way that what they're trying to basically apply it to would be the specific harmonics of a given circuit. And what that means is it ties in just like with that frequency response graph. It would be very similar, where in the middle would be the ideal frequency range. And then as we get further out in the lower end and further out in the higher end, you would see a roll off to it. And the way we look at that is it's a decibel response. So when, like he says here, the way we can, the rules that will apply by a factor of 2, that's considered octal, and then a factor of 10 would be, oh, he shows it actually here, because we're going to start getting into logarithms, and this is the fun part. And I don't know, has everybody worked with logs before? Have we ever had logarithms in like algebra and stuff like that?
Well, yeah, for me at least.
Because I could go through, and I mean, for me, the easy way to do it is something like this, where you just simply have like a log table. Because I don't want everybody going through and reinventing the wheel. That's just nuts. What we should have is just a nice table. So if we say, and generally what we're dealing with is logs to the base 10. So when we say like the log of 10 is equal to 1, log of 100 is equal to 2, and so on. And then of course the reverse, when we start getting into decimal ranges, that equates to negatives. So yeah, I'll go through, I'll post a log table up. I might even, I think mostly we're just going to stick to base 10 when we use these, if anything. So yeah, I'll post that up. I will have a homework posted up for chapter 34 today. And I did post a lab. I can't promise this lab is foolproof at this point. Like I said, I'm still very much playing around with this. So kind of poke with it. If it seems really chaotic or it's really difficult to do, that's fine. I just want, I want us all to get used to working with this simulator, and hopefully, we all get fairly proficient with it. I know it's a big change, but it seems relatively nice, and it does work. My biggest problem was working with everybody's platforms. That's why we didn't go with something like LT Spice, because LT Spice, you had to have a pretty nice computer at home to use. Otherwise, that thing would just, it would just chum. It would be awful. But so no, we're going to go through, and like I said, we'll go through logs. I'm going to take this, a bit at a time here. We'll just go through this first part of this chapter review here at this point, kind of end us at logs. I'll post a log table up, and then I'll have the homework posted up, and we'll have a week to do it, that kind of thing. I'm not going to push everybody real hard at this point. I actually don't know what your class schedules are like at this point. Probably pretty much like this with everybody else, I'm sure, different styles. But yeah, I have the log. Oh, I have a log. I have the lab posted up now, and I am calling that lab 1. So forget about the FET one I posted earlier. That one, it was just a little difficult, I guess, for everybody to use. So we won't be doing that. I do have an amplifier one up, just a very basic one, kind of roll through, get used, so we can start getting used to some of these concepts and things like that. And like I say, if you have any questions at all, I am pretty wide open. Text me, email me. I'm going to warn you, The weekends are a little rougher for me. I am still, I am actually working out there, unfortunately, and it's an essential job. Lucky me. So I still have to go. But yeah, I'm gonna end this here because I don't want to start getting into anything too new. Just like a basic intro here, but yeah, that's pretty much how we're gonna do it. We're gonna go through the rest of the chapters. I can't promise we'll make it to thyristors, but I would like to get up to that point, you know, oscillators and that kind of thing, and that would pretty much complete our whole overall here. I hope that works for everybody. And then, like I say, from this point on, I'll also, hopefully, as they promised me I would have my camera today, so hopefully I do. I'll be highly upset if I don't. No. But yeah, that's what I have for today. Hopefully this all work for everybody. And I'm gonna post. This will be my first attempt at doing a YouTube, so I'm gonna post these for each day for this